Hello, everybody. Thank you for joining this session on migrating your Oracle e-business suite applications to VMware with near or zero downtime. My name is Simon Cunningham. I'm a Senior Specialist Solutions Architect here at AWS. I've been at AWS for nearly 2 years now, and I've been in the Oracle space for over 2 decades, so a very, very long time. I'm joined here with Bala.
Hello, my name is Bala Nair. I'm a senior specialist SA for VMware at AWS. I have been with AWS for almost 2.5 years now. And prior to that, I was working with VMware for quite some time. So I'll begin with why VMware Cloud on AWS for Oracle applications. A lot of our customers are running VMware on-prem, where they set up the hardware and rack stack them and deploy the VMware software on top of that, and on top of which they deploy the enterprise applications. VMware Cloud on AWS is a service that VMware runs and operates on top of AWS infrastructure, and they deliver it as a service to the customers. The biggest advantage of that is the easy workload portability for customers because they can then move their workloads from on-prem to AWS without having to make any changes to their operations or to the application that runs on those workloads. This gives the customer a very consistent and familiar interface that they're already so much familiar with on-prem. So in terms of operations, they don't have to change anything as far as management is concerned. Another big advantage for the customer is they get direct access to all the AWS native services. Which will help them to achieve their modernization goals as they want to move their workloads to the cloud. Not only that, they can, once the migration is done to AWS, they can start looking at building new applications with using containers in combination with the virtual machines that they have. So the solution is built, as I said, on the AWS global infrastructure. So what VMware does is VMware takes bare metal hosts from AWS and they deploy their VMware Cloud Foundation stack on top of those servers. This stack comprises of vSphere, vSAN, and NSX, and vCenter, which every VMware customer would know is the management interface that is used to manage the VMware infrastructure. On-prem, the customer is already running vCenter on their own on-premises on the hardware that's running in the customer data centers. Once the VMware Cloud on AWS is instantiated, customers can access the vCenter and start using it just the way they would use the infrastructure on-prem. If they so want, they could interface these two vCenters together using hybrid link mode, wherein now they can then manage both these environments from a single pane of glass. This gives them the same operational consistency as they had across both these environments. And because it is running VMware on both sides, the movement of the VMs or the workloads from the on-prem to the AWS cloud becomes very easy and can be done without any changes. Since this is a service that removes a lot of operational overheads from the customer, as VMware is responsible for managing the environment, for upgrades, for patching, and all the day two operations that go on with managing this infrastructure, which then frees up the customer resources to go on and do, or rather, upskill themselves for the AWS native services. As I said earlier, there is a direct access to all the native services on AWS, And this allows them to build modern application architectures using the native services on AWS.
Okay, so some of the challenges with these traditional Oracle enterprise applications, such as eBusiness Suite, can be that these systems are fairly complex and they've been embedded within the organization, in some cases for over 10 years. And one of the main challenges is, these systems require highly skilled Oracle subject matter experts to operate and maintain these systems. And if you think from a migration perspective, again, customers can also face the same issue where the highly skilled staff are required to perform the migration. And with them being complex systems, one of the challenges can be that agreeing a downtime with the business. So having customers migrate or use VMC to AWS solves that problem. And again, we see in some customers they have a compelling event where they need to exit the data center within a strict timelines, and using VMC as a migration approach can be done relatively quickly with zero or near zero downtime, and effectively speeds up the migration for these customers. Okay, so Oracle application migration strategies. We're here to talk about VMware migration to VMC and also rehost versus relocate. So typically, a normal migration for eBusiness Suite in the first instance is to rehost the application. And as I mentioned earlier, there's a number of steps to perform this migration. And for any Oracle applications DBAs out there, they'll be familiar with this. So as part of the preparation, you would do a pre-clone. You would copy the files across, including the database, and you'd run some post-clone activities as part of that migration. And typically these steps will be done over a long weekend. It would incur additional downtime. And there would be a number of additional steps as well, because generally speaking, these Oracle applications have third-party systems connecting to the application, and they also have a number of interfaces, sometimes in the hundreds in some cases for the larger systems, which means that as part of the migration, a lot of these interface endpoints need to be changed, because as part of the lift and shift, the IP addresses change, which just leads to an additional configuration that needs to be done on the system. Now, if you look here, using a relocate, it significantly reduces the amount of effort, the amount of downtime, and one of the key benefits is you get to retain the IP addresses of the system. So this makes it from a migration perspective, it simplifies it massively, and it enables customers to move across with ease, without having to have highly skilled Oracle staff as part of the migration. So again, reducing the effort and the cost for that migration overall, and most importantly, the speed and downtime. Okay, so what we're looking at here is a traditional Oracle enterprise application migration using the lift and shift approach. And as you can see, there's a number of steps required, as I alluded to earlier. And I'm not going to go too much into detail here because we're focusing on the VMC migration, but just to give you an idea of as a comparison to using vMotion, which we'll come on to in a demo at the end of this presentation. So a traditional migration would use starting from the bottom, generally to reduce the downtime for the database. We would, in some cases, you could use an ARM backup and transfer that over to AWS. Now that could be transferred via S3, or it could be transferred in another mechanism such as data sync or the likes. And then we would use data guard to keep the database in sync. Moving up to the application tier, again, the files will be transferred using pre-clone and post-clone, which are eBusiness Suite terms for doing the cloning. And the application users would be redirected to typically an application load balancer, which terminates HTTPS, and then forwards the traffic onto the internal application tier within a private subnet. So that's just a typical example of a representative migration using a lift and shift approach. Again, so this isn't a full list of Oracle applications that can run on AWS, but you can see basically if it'll run on VMware on premise, then it will run on VMC. Okay, so the migration to AWS using the VMC approach comes in three. What we generally see is customers doing this in 3 stages. So stage 1 is where they optimize. So they'll do some form of assessment to make sure they're optimizing from a CPU perspective, and they'll typically just migrate that straight across into AWS seamlessly. And the second phase is what we like to call the refine phase. And this can, in the chart, you can see it's got year 1, year 2, but that's just a ballpark. Generally, this could be within a few weeks. This could happen or within a few months or up to a year in some cases. So in the refine stage, this is where customers start leveraging some of the AWS services, because once the eBusiness Suite systems in AWS, you can start plugging into AWS's services, and AWS have got the largest portfolio of services than any other cloud provider. So we've got over 200 plus services, and this is where customers, as an example, could start leveraging some of their services such as Amazon EFS, which is Elastic File System, and RDS Custom as another example. So they could migrate their database over to Amazon RDS Custom for Oracle as an example. So it's more of a hybrid approach, running on VMC and then using additional services from within that VMC cloud. And the third phase is the modernize phase. So this is, in my opinion, this is the interesting part where customers can start to use even more of the services, as you can see in the yellow box at the top. So this is where customers can use or take advantage or leverage some of the services I mentioned earlier, such as Athena and Analytics, which I'll cover off in the next slide. And as the technical debt reduces and the cloud maturity increases, customers use more and more cloud native services as part of that journey. Okay, so as I alluded to in the previous slide, AWS has over 200 plus services, and what you're looking at here is just some of the services I've listed here. Obviously, I can't include all of the services because the slide's not big enough. So just starting where customers can modernize their enterprise application. So just taking a step back, these Oracle eBusiness Suite applications have been heavily customized over the years, and what we see customers adopting is once they're in AWS, reducing them customizations back, reducing the customizations back to the core functionality. So reducing the system back to the core functionality and replacing them customizations with cloud native services. So for example, Amazon Textract is a service that can be used to scan images, text, or handwriting. And a use case for this could be for eBusiness Suite to scanning invoices and then use an automatic approval system as part of the workflow to scanning them invoices as part of the approval chain. So that's one use case. Another interesting use case which customers could do is Amazon Redshift. So as part of the Oracle footprint, customers typically have Oracle Business Intelligence, OBIE, as part of that footprint, which they use for their analytics. And one play could be customers migrate their Oracle database to Amazon Redshift, which is a purpose-built data warehouse, and use or retain the same application to connect to that backend database on Redshift. So one of the key advantages from that is customers can reduce their licensing footprint, and the business users can retain the functionality from the front end whilst changing the database. So Amazon Step Functions is another example where customers can leverage the automation that the cloud provides. And examples of this could be where customers are doing, they need to clone the environment or stopping and starting the lower environments to save costs, or automating the DR failover are other examples. And if you can think of the benefits of that, is where generally speaking, cloning can take 1 or 2 days, and it requires a lot of manual intervention. And automating that can certainly save a lot of costs and manual effort from an operational perspective. And again, we've got Amazon Athena and Amazon QuickSites. So these are more on the analytics side of things, and where customers can leverage a lot of the inbuilt cloud native services to query direct from the database or from a Redshift as an example, and also use Amazon QuickSites for visualizing the dashboards and reporting and these are all cloud native services.
Thank you, Simon. So as Simon was mentioning, once the customer migrates the workloads to VMware Cloud on AWS, they are able to free up the resources on premises and shift the cost models to the cloud. Instead of doing upfront procurement and deployment of infrastructure on-prem, they can scale the infrastructure on demand. While this is done, the customer can then leverage the advanced analytical services to draw more insights from the data. They can start innovating with the 200 plus cloud native services. And as they are free from doing operational management and upkeep of the infrastructure, they have more time to boost their skills and experience on the cloud, putting them on a faster path to application modernization. Now, let's look at how the connectivity from on-premises to the software-defined data center happens. As we instantiate the SDDC in the cloud, which takes roughly around 2 hours at the click of a button, we build a NSX edge inside the SDDC, and this is where all the connectivity happens from the on-prem environment. As you can see in the diagram, we have 2 ways of connecting the on-prem environment to the AWS cloud using VMware, which is through Direct Connect and through VPN. And the Direct Connect is not a mandatory thing. If, for example, the customer wishes to run in a hybrid mode for elongated periods of time, then it might be a good thing to have Direct Connect. But if it's a one-time migration, in most of the cases, an IPsec VPN, which terminates directly onto the NSX edge, which is a T0 router, a virtual router inside the AWS SDDC, is more than enough. And as you can see inside the SDDC environment, we have 2 other gateways. One is for management, which isolates all the management traffic going into the vCenter, the management VMs, which are basically the NSX and the HCX components. And then the other gateway is purely dedicated for all the compute workloads. And within that, we can create any number of logical network segments to isolate virtual machines and not having to talk to each other. For example, we could keep the app on a different segment and then the database on a different segment. and then apply firewall rules using the distributed firewall that's available with NSX to isolate those traffics. So this is at a very high level how the connectivity works from the on-prem to the VMware cloud on AWS. So this is how the demo architecture looks like, and this is what we've built in the lab environment. So as you can see on the right-hand side is the on-prem environment, wherein we have virtual machines running on physical hosts and connected to different VLANs. And on the left-hand side is the SDDC environment running on AWS, which is connected to a VPC using Elastic Network Interface. The SDDC is running in a dedicated VPC that belongs to VMware and it's managed by them. And the way we interconnect with the AWS native services is through the connected VPC. And once this connection is done, all the traffic that we need to flow to connect to the native services can happen over this. There are other network topologies also possible using transit gateway and all that, but it is not in the scope of this demo for today. So this is how the two environments looks like. Now let's look at how we do the interconnect between the two environments. So we deploy HCX components on both sides of the environment. So we have a HCX manager that sits in the cloud, and then a HCX connector that sits on-prem. And then we do what is called as site pairing. Once these two environments are paired, we are then able to do what we call as a network extension. So as you can see, we are extending the network, which is on-prem, to the cloud SDDC using the network extension function. Once this thing is done, then we can use vMotion to migrate the VM as is from the on-prem environment to the cloud. So it is as simple as this, as you see here, and this is what we are going to demonstrate to you in the demo, which will follow. So let me first walk you through the VMware Cloud Console. So once you log in to the VMware Cloud Console and you click on the SDDC that you have instantiated, you can see the summary of your environment. So as you can see how many clusters, how many hosts you have, but you do most of your configuration tasks from this tab basically, which is networking and security. And this is precisely where you will create those segments, as I mentioned. And if you're going to use VPN, you're going to connect your VPN using this section over here. And all the firewalling is configured over here using the management and the gateway firewall that I was showing you on the diagram. And very importantly, I want to show you that there is a connected VPC to which we are connecting, and that's visible over here. What I would like to show you now is the interface that you're all very familiar with. So this is our vCenter that we are running on-prem. And as you can see, I have an Oracle application VM that is running on the on-prem vCenter environment. And this is what we're going to migrate to the SDDC. And as you can see, it's connected to the Alpha Web Demo network. And I'm going to migrate this using HCX to the cloud SDDC. So let's begin from the top, wherein I walk you through the dashboard. So this is the HCX menu. And you can see I have done a site pairing from the on-prem environment to the SDDC environment, and I've created an interconnect, basically, which has these three appliances that get deployed on-prem, right? If I show you the topology, it will make more sense. So we have those three appliances. They are deployed on the on-prem environment, and then there's three appliances which are deployed on the cloud. And this basically makes the interconnect between the two environments. And then this allows us to create a network extension. As we can see, we have stretched three networks over here. The one I'm more interested is this one, the web demo. As you can see, this is the network to which the web demo, the VM that we want to migrate is connected to. So let's kickstart a migration. So this is the migration interface. We click on Migrate. We want to make sure the direction of the migration is correct. So we want to migrate from the on-prem to the SDDC. Now let's look for the VM that we want to migrate, which is sitting inside my folder. And I can find that here. So I choose the VM that I want to migrate. I click on Add. And then I need to specify the target container, which is basically the compute resource pool on the SDDC side, on the AWS side. Select a folder. I'll select my folder so that it goes into the right place. Here you go. Do that, and then from the storage, I'll select the workload data store, and then we'll select thin provisioning. And here is where the different options we have. So we have basically three different options. vMotion is just like what we do on-prem. So this is what we're going to demo today. And then there's another option called bulk migration, which is also works for environments where you can afford to have a little bit of downtime. And it also one of my favorite methods, because with this option, you can leave a copy of your virtual machine on-prem. So in case something goes wrong, you have a way to go back to your original VM. And then we have a way to schedule this. So you can schedule the time, the date and the time when the flip over needs to happen. So you don't have to do it at the same. But for the sake of this demo, we'll do it now. And then in the switch over options, you have the ability to remove the snapshots and force unmount any ISO images. And with the extended options, we can even select to migrate the custom attributes of the virtual machine if there are any on-prem. So once this is all done, we can click on validate, and hopefully the validation should be successful. So here I have some warnings which says, please review them before proceeding. And that's basically, it says that the requested storage will overcommit the data store. So we can ignore that. Then we click on go. It's going to create a group name. And then when I click on go again, it's going to start the migrations, right? So here I can see now that the migration task has started. It will start doing the base sync between the two environments, and then it will flip the VM over. So for the sake of this demo and for the sake of time, we've already done the migration of these VMs beforehand. So as you can see, we've done this before, and it takes roughly 5 to 6 minutes to do the migration of this VM. So for the demo now, we can go to the SDDC vCenter, as you can see here, and you will see that the VMs have already been migrated. So we have two virtual machines in the demo today, and Simon will go through those in details, but let me quickly show you what they are. So this is the Oracle app, and as you can see, this is quite a big VM, so it would not fit into our demo schedule. So we had migrated it earlier. So the app and the database, they're both sitting on the SDDC, and I'll hand it over now to Simon to take you through the rest of the demo. Over to you, Simon.
Thank you very much, Bala. Okay, so just to articulate the adding a couple of additional services onto the VMC environment, I have selected one is an application load balancer, and the second service is Amazon Elastic File System. And as part of the migration, we've added the application load balancer onto this environment, and we have terminated the HTTPS at the load balancer. So Route 53 is an Amazon AWS DNS service. And what you're looking at here is you can see the A record we have created, which is EBS on VMC .local domain. And this has been configured within the application. So moving on to the application load balancer we've configured in AWS to connect to the application tiers in VMC. You can see here that the application load balancer we've created is an internal application load balancer. And this is where the users will connect to the application, and these will be terminated using HTTPS. And the list is configured to point to the application tier in VMC. So you can see here, you would point it to the registered target. So that's that's the application tier within VMC. And just to confirm the health check, it's alive and okay. In terms of monitoring, this should report, yeah. So we can see here it's reporting healthy. So that's good. Okay, now moving back to Route 53, the DNS service we talked about earlier. And just to demonstrate that the application is using the DNS endpoint we created in Route 53, I'll quickly show you the A record we created earlier. So this is a local hosted zone. And within here, we've created a record for the application to use. So the application has been configured with this EBS on VMC.local domain. So now I'll just quickly flip back to the Windows client. So just to demonstrate, users connecting through that application load balancer, you can see here the URL is HTTPS EBS on VMC. So that's using the DNS record in Route 53, and that Route 53 record is pointing to the application load balancer in AWS. You can see here. And just to demonstrate another service, here we've created a Amazon Elastic File System, which is an NFS file system within AWS. And we've mounted that on the application tier as a file system, hosted it in VMC. So here you can see we're using another service in AWS and mounting that on the Linux VM hosted within VMC. Okay, so back to the putty session on the application tier within VMC. I'm just going to demonstrate that we can see that file system from within the VM. And here you can see the EFS mount point here. So this is effectively a VM in VMC, which is using the Amazon Elastic file system within AWS. So I've just demonstrated a couple of services here, but again, there's many services you can utilize within AWS. Just to give you an example how we could benefit from just using the EFS file system, that could be a shared storage file system you want to use for storing any backups or any interface directories and the likes. Thank you very much for joining this session, and we look forward to seeing you again in another session. Please feel free to reach out to either of us via email, and we'd be happy to help.
Thank you.